In this video, we're going to be taking a closer look at isosceles and equilateral triangles. First, we're going to start with isosceles triangles. We're going to start with this isosceles triangle over here, ABC. We want to discuss what some of the parts of an isosceles triangle are. First and foremost, we're going to talk about the legs. The legs of the isosceles triangle are the two parts or segments that are marked congruent. So that would be segment AB and segment BC. The legs of an isosceles triangle are always congruent. So make sure you get that part into your notes. Next, the angle where the sides intersect is called the vertex angle. And the sides that we're talking about are the congruent sides. Really, it's the legs. Where the legs intersect is the vertex angle. So that's angle B. Or in our case, also angle 1. The side opposite the vertex angle, so over here, this is going to be called the base. The base is always the oddball side. So the congruent sides are the legs, and the base is the oddball side, the non-congruent side. Opposite the base is the vertex angle. Opposite the vertex angle is the base. So then what do we call angle A and angle C? Of course, we would call that the base angles. So angle A and angle C are the base angles. Now down here we have the isosceles triangle theorem. First, let's give it a read through. So if two sides of a triangle are congruent, essentially saying if you have an isosceles triangle, if two sides are congruent, then the angles opposite those sides are congruent. So what we're saying is, if this side is congruent to this side, then the angles opposite those sides are also congruent. So angle 2 and angle 3 are congruent. So angle 2 is congruent to angle 3. Really want to get into your notes what I have written here. The whole piece is if AB is congruent to BC, then the angles opposite those congruent sides are also congruent. Next, we have the converse, and the converse is essentially just the opposite direction, or the reverse of what we just said. So what this says is that if you have two angles that are congruent, then the sides opposite of those are congruent. So first, if you had angle 2 and angle 3 being congruent, then the sides opposite them are also congruent. So let's get that into our notes. All right, now let's try to put some of this newfound knowledge to work. Now the first thing I see here is that these two sides are marked congruent, so I'm dealing with an isosceles triangle, which tells me that the angles opposite those sides are also congruent. So if angle L is 68 degrees, then angle J is automatically 68 degrees. And then I know that all three angles add up to be 180 degrees because of the triangle sum theorem says that all three angles add up to 180. So if I take 68 plus I don't know, I should get 180. I'll combine like terms, subtract from 180, and I should get that the missing value is 44 degrees. So the vertex angle is 44 degrees. Okay. Next, number 2. I see that I have two sides marked congruent. So again, I have an isosceles triangle, only this time D is my vertex angle. How do I know? It's the angle that's between the two congruent sides versus 68 was opposite, right? The two congruent sides. So since D is 106, I'm going to take 180 and subtract 106 from that. When I subtract 106 from 180, I get 74. So what is 74? Angle C and angle E add up to 74. But I know that they're the same. So if I take 74 and divide that by 2, I get 37 degrees. So this is 37, this is 37. And if I add up 37 twice plus the 74, I should go back to 180. On example number 3, I see that I have x is 77 and z is 77, which means these two sides, right? The sides opposite the congruent angles are also themselves congruent, so this must be 12. I can take the 77, add it to the other 77, plus some unknown, that equals 180. After combining like terms and subtracting from 180, I'm going to get the unknown angle is 26 degrees. And what are they asking for? The measure of angle y is 26 degrees, and the length of YZ is the same as XY, which is 12 centimeters. Okay, those last two were numerical examples. Now we have algebraic examples. So again, I see that I have two congruent sides. That means that the angles opposite them are congruent. Now keep in mind, if I have congruent ideas or terms, then I set the terms equal. So I have 8x minus 30 and 5x plus 9. So if they're congruent, then 5x plus 9 must equal 8x minus 30. Now you can finish the algebra on this one, so I'm just going to move on. It's all set up. It just says find the value of the variable, so when you're done, x is the final answer. Over on this other side, number 5, looks like we have an isosceles triangle again, and these are the base angles. They must be congruent, so 4x plus 7. If they're congruent, then I set the terms equal, equals 9x minus 33. I go ahead and I solve for x. So part of your mission is to complete these problems. 6 and 7, nothing really crazy happening here. This time the algebra has to do with sides. Are the sides congruent? Well, I notice that the angles are congruent, so the sides opposite those congruent angles must be congruent as well. 74 is the same as 74, so those sides opposite must be congruent. So if congruent, set the terms equal. 15x plus 7 equals 23x minus 17. Once I solve for x, I'm good to go. And same for number 7, identical setup, so go ahead and set up number 7 and complete it. So far you have 4, 5, 6, and 7 to finish on your own. Now for number 9, the first thing I see is triangle DEF. So let's draw triangle DEF. Now it doesn't really matter where you put the letters, it matters what we do after. They say that angle D and angle E are congruent, so angle D and E are congruent. DE is x plus 4, so this is x plus 4. EF is 4x minus 8, this is 4x minus 8. And DF is 7x minus 35. So we need to find the value of x, and then we're going to find the length, or the measure, of each side. Well, which sides are marked congruent? Well, opposite the congruent angles are the congruent sides. So who do we set equal to each other? You guessed it, 4x minus 8 and 7x minus 35 are the two congruent sides, so that's who I'm going to set equal. 4x minus 8 equals 7x minus 35. You finish out, get the value of x. That goes here. Then you can substitute the value of that variable in for all of the x's, respectively, to get the rest of the answers. So now you have to wrap up number 9 on top of the other problems that I gave you. Number 10, very similar, triangle WXY. So here's W, X, and Y. The next piece of information that they give us, or I should say the first critical piece, is that WX is congruent to WY. WX is congruent to WY. Then they tell us that angle W is x plus 6. So in here is x plus 6. And angle X is right here. That's 5x minus 12. And angle Y is right here. That's 7x minus 48. Now, which of these angles are congruent? Keep in mind, opposite the congruent side are the congruent angles. So opposite this side is that angle, and opposite this side is that angle. So it looks like 5x minus 12 and 7x minus 48 are the congruent angles. I'm going to set them equal to each other. I'm going to solve for x, and I'm going to place that here. Then I'm going to take that value of x and substitute it into each of the angles and get the 3 angle measurements. Now things, if they work out correct, these 3 values should add up to be 180. And that's how you'll know if you're right. Now you can finish that one up. The equilateral conversation goes pretty swiftly because we've already really talked about this in class. A triangle is equilateral if and only if it's equiangular, right? If and only if. You cannot have one without the other. So if angle A equals angle B and angle B equals angle C, then we know that AB, this length, is equal to BC, this length, is equal to AC, this length. Automatically, if you have the angles, you have the sides. Conversely speaking, if AB equals BC equals AC, so if you have those side lengths, then angle A, B, and C are also equal. So the measure of angle A equals the measure of angle B equals the measure of angle C if all of the sides are congruent. So again, if you have one, if you have equilateral, you definitely have the equiangular piece as well. So if you see this congruent notation on the sides, you can automatically put the congruent notation on the angles and vice versa. Now let's put this information into action. On this first example, we're given that angle A is 60 degrees and angle B is 60 degrees. So 60 plus 60 plus I don't know equals 180. Now we've talked about this in class. If 2 of them are 60, this is automatically 60, but this adds up to 120 plus x equals 180 if you forgot. And when you subtract from 120 from 180 on both sides, you're going to get that x is 60, or that unknown angle is 60 degrees. So angle C is 60 degrees. At this point now, we understand that all the angles are congruent, so that means automatically all the sides are congruent. So BC then is 9 feet, and AC is 9 feet. Now it's really easy when it's equilateral and equiangular. And just to point out, we include the units when they do. Number 12, slightly different. By different also, I mean it's almost even easier. They give us right off the bat that all 3 sides are congruent, so this one I know that it's equilateral right from the get-go. So that means all sides are 24 centimeters. So that's 24 centimeters, and that's 24 centimeters. And since both sides, or all 3 sides are the same, I know that all 3 angles are also the same, so these are all going to be 60, 60, and 60. So for all 3 of these lines, it's 60 degrees, 60 degrees, and 60 degrees. Piece of cake. Let's move on to something a little bit more challenging. Here they tell us that triangle PQR is equilateral, which means all sides are congruent and all angles are congruent. And all the angles in an equiangular triangle, remember, are equal to 60 degrees. So what do we have here? It looks like we have some y stuff that all correspond to sides. So what do we know? It's equilateral, so any 2 can be said equal to each other. So for instance, 4y minus 59 is equal to 9y plus 1. Or 11y minus 23 is equal to 14y minus 59. I suppose if given the choice, I would try to find 2 that just have addition on both sides or whatever, but really doesn't matter. Solve for 1 and get the value for y. It says just to solve for x and y. Now these are both true and solvable, so either one will work. But then they only give us one algebra expression with the value x in it. And it doesn't have anything to do with the sides, it has to do with this one particular angle. But again, because it's equilateral, I know that all 3 angles are 60 degrees, so 7x minus 3 isn't equal to another algebraic expression, it's just simply equal to 60, because that's the value of that angle. That's easy to solve for x. So you have plenty of problems to wrap up here, and then you can move on to the homework when you're ready. Hopefully this was helpful, and then feel free to check things in with me or ask any questions should you have them. Good luck.